The classic 500/1 from JL Audio, this being the V2. So we've got our 12 volts coming in here for the SMP, which is just a regular transformer push-pull from the power supply FETs, which are all absolutely cooked. We'll get to that later. Pulses are generated for these FETs by UC3525 IC. This power supply generates a single rail voltage. We've got a dual rectifier there, and that single positive rail voltage is stored in these rail caps. Now this is a full bridge amplifier, so essentially there's two channels that are in push-pull on the speaker terminals, and because this only has one single positive rail voltage, there'll always be about half rail DC voltage on the speaker terminals at all times. Got two FETs per channel, one high side and one low side. And this is obviously class D, so we've got the output filter inductors, and the rail voltage is actually quite high for what you'd expect from a 500 watt amplifier, because this amplifier does the 500 watts from 1.5 ohms all the way up to 4 ohms. So it has a similar kind of rail voltage from what you'd expect from a full bridge 2000 watt RMS 1 ohm amplifier. A cool feature when it comes to repairing these is all of the output drive circuitry and the preamp comes alive before the full rail voltage is built, and that's because there's a separate little transformer set up here with a MOSFET that drives this transformer, and that generates all of the auxiliary supply voltages for the drive circuit and everything, and only after about 5 seconds after that has been activated do the main rails come alive on the main power supply. So if there's any drive circuit issues or faults, you can diagnose those without the full rail present. Now despite this being a pretty clever amplifier, there's no health check mode at startup, so this amplifier has shorted the MOSFETs on one of its channels, the output FETs here. These two are totally dead. These two are absolutely fine, but because we have shorted output FETs, when the amplifier has tried to power up, it's been unable to drive obviously current into that dead short, and it's overloaded all the power supply FETs and smoked these all up. So this thing is going to be a full rebuild. We need to replace all of the output FETs, even though these two are fine, might as well replace them anyway. There's a 47 ohm resistor here that looks a bit burnt out, and that leads to the 4427 drive IC, so that's probably toast as well. So FETs, obviously all of the power supply MOSFETs need changing, all of the gate resistors need changing, these burnt ones here, and because these gate resistors are burnt, that means that they've dumped current through these drive transistors here, so they might need changing as well. So we've got all the power supply FETs, gates, output FETs, and also the 4R7 that was burnt removed. Now if I hit the remote to turn the amplifier on, you see we're drawing 0.4 amps idle current. And let's first make sure these 4 drive transistors are okay for the power supply. Nice clean PWM on bank 1, and nice clean PWM on bank 2. Excellent. Now even with no FETs in, this amp just has a green LED, and you can see here, like I said, because we've got this separate auxiliary supply transformer, all of the drive circuits up and running here on the output section. So if we probe one of the gates here, you can see we've got some gate PWM on the output FET location. Now not all of them look as clean as that. For example, that one's like that, but knowing these amps, I'd say that the drive IC is okay. That 47 ohm resistor wasn't leading to the supply of the chip. That's this 10 ohm resistor that's in series with the VCC. That's fine. And one of the best ways to see if the drive IC is definitely dead or maybe okay is to have a look at the thermals, and you can see here it's running absolutely stone cold. There is actually a way to get visible PWM on all of these gate pads on these amps using some methods which are dictated in the bcae1.com amplifier repair guide. And if you want to buy this guide for yourself, just go to bcae1.com, click on the full amplifier repair tutorial and download it. Make sure you have Ruffle browser extension installed so that the flash content works. But I've done enough of these amps to know that that looks okay to me. So we're going to load up new resistors, new FETs on the output and the power supply, new 47 ohm resistor, and see what happens. So all new power supply FETs, gate resistors, output FETs, etc. So what we're going to do is a little cheeky power up, but we're not going to let it build the full rail voltage just yet. I'm just going to tap the remote one time like this. And what that's going to do, as you can see, 0.4 amps of current draw is going to get this auxiliary supply transformer up and running, just to make sure that we still have good pulses on the gates of these FETs. Like, see, here's number 1. You can see the pulses there up here just before going to DC. That's good. And then the other side, yeah, it looks a bit different, but... And this next one, yeah, some pulses there. And the last one, yeah. So now I'm going to hold my foot on the remote and build a little bit of rail voltage, just a touch. I'm going to turn the current right down so it builds rail voltage slowly. We're going to probe the 2 low side output MOSFETs that are going to have the square wave PWM on them. And because the rail voltage is going to build slowly, we'll get a really good view as to whether everything's happy as it's building the rail. So let's have a look. Probe low side drain. So as the rail starts to build, should get some... Oh, there we go. See how the rail built up a little bit there. Now I've let go of the remote. Let's check the other low side FET. That's looking healthy as well. So the last thing to do then is hold my foot on the remote, build a full rail voltage, make sure the square waves still look as good as they did just now, make sure there's no excessive current draw, and that the FETs don't get overly hot. Here we go. 1, 2, 3. There we go. 1.6 amps idle current, healthy looking PWM, and no excessive heat on the MOSFETs. That means she's ready to go.